Shanghai Tower, a towering structure that defies the sky, was built through an incredible journey from foundation to summit. First, its foundation was reinforced with massive 90-meter piles to protect against the city's seismic risks. Then, a spiraling steel skeleton extended into the sky layer by layer, and an aerodynamic design was implemented to reduce wind force at each floor. The reinforced concrete core gave the building both durability and flexibility, while the glass facades curved like a dragon, reflecting the sky. More than 30,000 workers and engineers worked in harmony throughout the construction process. Giant cranes lifted the components into the air, transforming each phase into a breathtaking spectacle. Finally, reaching 632 meters, Shanghai Tower left its mark on the heavens, a living testament not only to China, but to the entire world's engineering prowess. Raffles city Chongqing rose like a giant city suspended in the sky. Situated at the confluence of two rivers, this magnificent project made its mark on architectural history with its 8 towers and the 300-meter-tall crystal connecting them. First, deep foundations were dug to reinforce the ground. Then the towers were gradually erected upwards, while massive cranes skillfully placed steel segments in the sky. With Moshe Safdie's inspiring design, the sail-shaped towers became the city's symbol, while Arup's engineering marvel system added extraordinary durability to the structure. This complex, which includes everything from residences and luxury hotels to offices and a massive shopping mall, became more than just a building. It became a completely different living world perched high above the sky. Tunnel construction is one of the most challenging yet fascinating fields of engineering. In the first phase, the route is determined through detailed geological surveys, meticulously analyzing the rock structure, groundwater, and soil conditions. Then excavation begins. The mountains are carved like a sculptor using massive TBMS, tunnel boring machines, or blast boring methods. As excavation progresses, temporary support systems are quickly installed, including steel arches, shotcrete, and anchors to secure the tunnel. Waterproofing is then installed, the permanent concrete lining is poured, and modern ventilation, electrical, and fire safety systems are installed. The end result is a safe, illuminated, and modern roadway through the dark mountains, an engineering marvel that not only connects 2 points, but also connects cities and people. Bridge construction is one of the most impressive encounters between nature and human ingenuity. First, ground surveys are conducted to determine the abutments, and massive pile foundations anchor the structure to solid ground. Then the towers, or piers, rise toward the sky, each erected like a backbone that will eventually support giant steel cables or girders. Steel cables are stretched across the sky using cranes, weaving them like a giant web, and the deck segments are gradually suspended or slid into place. Through concrete pouring, welding, and meticulous assembly, the bridge gradually connects the two sides. In the final stages, asphalt paving, lighting, railings, and modern security systems are added. Finally, this giant structure, gliding across rivers, valleys, and seas, not only facilitates transportation, but also becomes a magnificent symbol of humanity's power to transcend borders. Constructing a water pump is a seemingly simple yet life-saving engineering feat. First, the closest and most suitable location to the water source is selected. Then, a solid foundation is laid. As the body is assembled, components like the shaft, impeller, and valve are meticulously placed. Each component combines to transform the flow of water with force. The motor or hand crank mechanism is then added to bring the pump's heart to life. The pipelines are connected, the inlet is protected with filters, and the outlet is securely secured. During a test run, the effort is rewarded when you first hear a quiet hum. Then the powerful jet of water gushes upward. This small but effective structure becomes an unsung hero, irrigating fields, bringing life to homes, and uniting villages.
This giant structure lifts a ship 113 meters into the air. Chinese engineering knows no bounds. Introducing 3 gorgeous ship lift. Imagine an elevator. But this elevator doesn't just carry people, it carries ships weighing 3,000 tons. And it only takes 40 minutes. This giant machine on China's Yangtze River overcomes the 113-meter level difference created by the dam in a single move. At the heart of the system is a giant steel platform. This platform moves on rails without deviating an inch, while ships glide into this structure as if they were entering a spaceport. Everyone who watches is left speechless as giant engines, working with a lifting force of 6,400 tons, pull the platform upwards. This is not just a cable that runs under the water. It is the key to the digital world. In northeastern China, off the coast of Dalian, there is a huge power quietly rising. The Dalian Submarine Cable Network. This system connects China directly to America, Japan, and the rest of the world with thousands of kilometers of cables laid on the ocean floor. But what is truly incredible here is the machines working at the heart of this network. These giant structures that lay cables on the seabed drag tons of cable rolls and place them deep into the ocean with millimeter precision. The cable plow machines, lowered hundreds of meters under the water, cut through the seabed, bury the cable inside, and protect the signal from external influences. Thanks to these machines, China's Dalian port has now become a superhighway of digital data. Can you repair a ship without setting it afloat? Answer: dry dock facility. This huge system is one of the most fascinating wonders of marine engineering. When a ship docks in port, you think it is tied to an ordinary dock, but within a few hours, this huge structure drains the water and completely dries the ship. Yes, you heard right. Ships weighing thousands of tons are lifted out of the water as if they were placed in a box. This is where the real show begins. Bridge construction is one of humanity's greatest displays of power to overcome nature. It all starts with massive foundations driven tens of meters deep. Then, tower cranes lift steel beams weighing tons into the sky, while welding machines set off a symphony of sparks. The segments are brought closer together inch by inch, and when they finally come together, what emerges is not just a transportation route, but a giant corridor connecting the sky. The construction of a mega container ship is among the largest man-made structures in the world. It all starts with the cutting and bending of giant steel plates in the heart of the shipyard. Then giant cranes come into play. They place the compartments, each weighing several tons, into the hull with millimetric precision. As the hull is built, the resulting structure grows like a sea monster. With a length of over 400 meters and a width of 60 meters, this colossal structure is designed to carry thousands of containers. Special rail systems and automatic guide rails installed on its deck ensure that each container fits in the right place. This is not just an airplane. It is a giant engineering feat that challenges Boeing and Airbus. When the parts of the C919 arrive at this factory, thousands of components, each prepared with millimeter precision, are assembled with giant cranes, automatic positioners, and robotic systems. The production line works like an orchestra as the fuselage segments, nose section, wings and tail section are assembled one by one. The structure, which is controlled with laser measurement systems at every step, finally turns into a real passenger plane when the engines are attached to the fuselage. In the world of shipbuilding yards, which operate like a battlefield rather than a factory, are one of the most incredible points where human intelligence and steel meet. Everything starts with cutting and bending giant steel plates. These plates are prepared with millimeter precision with laser cutting machines, and then placed in place with the help of giant cranes. In the block production system, each part of the ship is assembled separately and then put together like Lego. This huge facility was built on Hainan Island, at the southernmost tip of the country. But what makes this place special is not just its location, but its strategic power. Because the rockets launched from here can carry much more load with much less fuel, because they are closer to the equator. At the heart of the facility, China's most powerful carrier rockets, the Long March series, are assembled. Each rocket is lifted into an upright position by giant cranes and undergoes final tests on the giant launch pads where they are placed. This is not a hospital, it is an engineering marvel. Huoshenshan Hospital was built in just 10 days in Wuhan, China, and has been admired worldwide. The colossal structure, which was laid in 2020, was completed on February 2nd and accepted its first patients on February 3rd. With a total bed capacity of 1,000, the hospital covers an area of 60,000 square meters and is equipped with 30 intensive care units. More than 7,000 workers worked in 3 shifts on this extraordinary project. At the heart of this vast facility, giant turbine towers rise, anchored meters deep in the sea. Each exceeding 100 meters, these structures are erected in the middle of the ocean by special crane ships. But the most fascinating part is the assembly of the giant rotors. The giant propellers are placed on top of the turbine without deviating an inch, and once they start spinning, they turn into steel dragons that scream into the sky. The engines of this system deliver hundreds of thousands of kilowatts of energy per hour, feeding the entire coastal area. The Fehmarnbelt Tunnel not only pushes the boundaries of engineering, but also truly demonstrates the power of giant machines. These huge tunnel sections are not built on land, but in specially designed pools in the middle of the open sea, and each one is approximately 217 meters long. Giant crane systems carry these sections. Then huge excavators dig into the sea, and these concrete giants are placed underwater with millimeter precision. When each section is assembled, an 18-kilometer-long steel passage emerges. This project is not only the longest underground tunnel in Europe, but also proves how limitless giant tunnel boring machines are. Each 200-meter-long giant excavation machines advance by pushing the rock layer in front of them. They dig, grind, and place the tunnel walls from behind at the same time. Such a system that these machines open a tunnel extending 2 kilometers underground in an instant and leave behind a structure completed with millimeter precision. This huge project not only transfers wind energy from the north to the south of the country, but also goes down in history as one of the longest and most powerful cable lines buried underground. But the real show begins in the giant machines that place these super cables deep in the ground. Specially designed giant cable-laying vehicles lower the cables weighing tons into the ground meters deep and place them with millimeter precision. Giant digging machines coming from behind simultaneously open the ground, lay the cables, and then cover the ground again. The giant glass structure placed on top of an old port warehouse building is not light. It weighs tons. And the reinforced concrete core carrying this weight was raised with millimetric calculations. One of the most striking moments here was the placement of the 12,000-ton roof. Special crane systems placed these giant glass pieces in place as if they were working with needles. In addition, the walls inside the hall were carved with robotic milling machines so that they would perfectly reflect sound waves. Each was shaped at different angles and placed one by one. This is not just a liquefied natural gas terminal, but a huge choreography of machinery where giant tankers dock, where the liquid gas is transported to land, where it is converted into gas and distributed for miles. The real stars here are the floating regasification units and the giant transfer systems attached to them. The millions of tons of gas tankers dock on the shore, where the giant pipe systems automatically dock with the ship. Special pump systems transport the liquid natural gas to land in seconds, where it is then converted back into gas by giant heat exchangers that resemble jet engines. Not only does it connect 5 countries from Estonia to Poland with high-speed trains, but it also pushes the boundaries of engineering with its giant machines used on the construction site. The most exciting part of the job is the track-laying process. Automatic track-laying trains unload hundreds of meters of steel rails in a single move, and the connecting machines that come after them fix the rails by making millimeter welds. But it doesn't end with just laying the rails. NordLink underground power cables. This huge project is a giant energy backbone that passes under the North Sea, reaches the land, and is then buried meters below the ground. But the real astonishing part is hidden in the machines that lay these super cables underground. Special cable-laying machines pull the kilometers-long heavy cables from giant drums and place them deep underground with great precision. Simultaneously operating excavation systems open the soil, lower the cables, and the following pressing machines secure the area around the cable. This is no ordinary factory. It's a giant technological arena where battery production meets insane automation. The moment you enter, hundreds of robotic arms are processing lithium cells with micron-level precision. Giant mixing machines knead the active materials into dough. Then, on infinitely long production lines, the electrode layers are laid out layer by layer, just like a giant printer. These layers are then quickly rolled up by robots, pressed, and sent to high-temperature ovens. Everything moves with millisecond calculations. A giant energy plot rising secretly under the scorching sun of the Sahara Desert, Project Desertec. But this is not just a few solar panels. It is a giant energy factory powerful enough to connect the continents. At the heart of it all, there are hundreds of thousands of heliostats arranged like mirrors. These mirrors reflect the sun's rays flawlessly to the giant towers in the center. What is in those towers? Giant cauldrons filled with liquid salts. The reflected rays heat these salts to over 1,000 degrees. And then this heat starts to spin the turbines wildly. This is not just a science center. It is a nuclear monster trying to bring the power of stars down to Earth. And it all starts with a monster of a machine, full of giant magnets, vacuum chambers, and plasma confinement systems. At its heart is a giant steel ring called a tokamak. This ring creates magnetic fields to hold the super-hot plasma, which reaches millions of degrees. So hot that hydrogen atoms collide and fuse at that temperature.